Well, folks, this is Guruji Online, and I am Sanjay speaking from this platform. Today, we will solve some typical problems pertaining to our electricity chapter. This is one problem which is on the board, and it has come in the real-time JEE Mains exam. So, in this question, you are given a rod and here charge Q is there and here charge 2Q is there, and there is another weight of W at the x distance from this bearing. Another charge Q is there on the ground like this, just below this at a distance of h. This bearing is basically, this is in between the rod, and this is L by 2 and L by 2, and this is x distance. So we have to find x when rod is horizontal and balanced. Means when the rod is at equilibrium. Now, let us draw the free body diagram of this rod. We will have the repulsive force here and repulsive force here, and there will be a force due to this weight, and of course there will be a normal reaction here. So this is the rod. This will be, suppose this will be F1. It is the repulsive force from Q to this charge, and this is the force because of these charges, and of course in between there will be a reaction, and here W is given. So this is X, this is L by 2, and this is your L by 2. This is a simple free body diagram of this rod due to various forces acting on this. Now, at equilibrium, basically torque, this must be 0, and of course force should also be, these two conditions should be fulfilled. So if we take the torque from this point, then this F1 will be like this. This will try to rotate the rod like this, F1 into this distance, F2 into this distance. This will try to rotate the rod in this direction, and this will try to rotate the rod in this direction, this way. So let us see, this is rotating the rod anti-clockwise, and this is rotating the rod. It is also anti-clockwise. Sorry, it is clockwise, and this is anti-clockwise, and this is clockwise. So that means F1 plus, sorry, F1 into this distance L by 2 plus W into X must be equal to F2 into L by 2. Clockwise moment must be equal to anti-clockwise moment, and this will give you torque as 0. Now here F1 is nothing but K Q H square. F2 is nothing but K Q, here it is 2Q into Q upon H square, where K is nothing but 1 by 4 pi epsilon 0. So in the first part, basically we know all these values, and putting all these values we can get X from this equation. Now the second part which says find out H when there is no. Now it says that for this Fn to be 0, what should be the value of H? So here basically F1 plus F2 must be equal to plus F plus Fn must be equal to, because these are upward forces and these are downward forces, must be equal. Here for this to be 0, that means W must be equal to F1 plus F2. We know F1, F2, W. Here there is no X is there, so we can find out what will be the H which will satisfy this equation. So this is an electricity problem, electrostatic forces involving electrostatic forces, but basically it is the simple mathematics. We can solve it by just our mechanics simple formulas. Vertical forces, balancing vertical forces, balancing torques, and apply the mechanism when the things are at equilibrium. So this was the real-time question, real-time problem it was asked. So basically in exam, generally electricity and magnetism, within both the chapters, this mechanics is added and the questions are made. So your mechanics must be strong enough. So now let us go to the second question. Now in this problem, basically two copper coils are given, they are 1 meter apart. And every copper coin is having 3 into 10 raised to 22 atoms. So generally we know that the charges on electron and proton are same, and that's why they remain neutral. these coins will be neutral. But here in this case, basically charges in this coin, charges between electron and proton, they differ by 0.00010001%. So let us see due to this difference what is going to happen. So what will be the, basically what is given is QE minus QP is nothing but this is 0.000, then another, because it is given in percentage. So here QE minus QP, we can write here 1.6 into 10 raised to minus 19 into 0.000001. This is Coulomb. So this is the basically delta Q. This is the basically delta Q charge this copper coin they will have in one atom, but total delta Q will be, there are 29 atoms in one molecule. So 29 into how many atoms are there is into this. This will be basically the charge difference between the two copper coins. This will be charge here and this will be the charge here. So they are going to, since they are going to repel each other, so what will be the force? K delta Q into, that is R square, or we can write it as K, we know 8.99 into 10 raised to 9 Newton into whatever value is coming divided by 1 meter square. When you will solve this, your answer will come like this: 1.7 into 10 raised to 8. You see how big this force is. With a little difference between the charges, this much of force they will be experiencing, repulsive force, this copper coin. So now let us go to the next question. So let us see this question. This question says, how far must be two protons if electrostatic force acting on either due to the other must be equal to gravitational force on the proton on the surface, Earth surface. So suppose two protons are there, and if there is a r distance between them, then what will be the electrostatic force? K Q P, that is the charge on the proton, square upon r square. And if this proton is on the surface of the earth, then what will be the force? That will be nothing but m into g. That is mass of the proton and your gravitational acceleration. So this, we can equate these two. So r, we can find out r is nothing but k upon mg root correct. So we can put the values. K we know, m mass of the proton we know, g we know, and q p charge on the proton also we know. So we can find out the distance between the proton. If you put all these values, then it will come as 0.119. So this is the distance that they will experience the same forces as a gravitational force. So now let us go to the next problem. Well, this question is like this. You have two spheres, identical spheres. This sphere is having charge Q. Suppose you transfer alpha times this charge to the sphere number 2, then we have to find out the force, electrostatic force between these two. We have to find out basically what value of alpha maximizes the force between the spheres. So suppose if this alpha q is transferred here, then naturally this will be having this much of charge. So these are two charges between two spheres. So what will be the force? K Q alpha Q 1 minus alpha divided by, well, this is r distance, this is given and this is fixed. This is r. So we can write it as k q square alpha 1 minus. This is a constant quantity. This is not varying. Only we have to maximize this alpha. So, by looking at this equation, we know that this will be, suppose if we solve it, then this will give you, it's a quadratic equation, this will give you a parabola. So this is a graph between alpha and f, and this will be nothing but, when alpha is 0, this f is 0, and when this alpha is 1, then again it is, f is 0. So this is basically 0 and 1. Because of symmetry, we can find out that at alpha is equal to 1 by 2, this will be maximum. And this is a series of parabola. So at alpha will be, this will be nothing but 1 by 2, this f will be maximum. Now that's the, for section A, alpha has to be 1 by 2 for giving the force as maximum. But what is the larger and minimum value of alpha for f by 2? F by 2 means this is. So basically these values we have to find out. Now we already know that alpha 1 by 2 it is maximum. So this is f max is nothing but k q square upon r square into 1 by 2 into 1 by 2. That is k q square upon 4r square. Now for problem B, it is f max by 2. So this will be k q square upon 4r square into 1 by 2 must be equal to k q square upon r square to alpha 1 minus so this is a quadratic equation, alpha 1 minus alpha is equal to 1 by 8, or alpha square minus alpha plus 1 by 8 equal to 0. This is a quadratic equation, and from this we can find out the value of alpha by our simple algebra, and this alpha will come as 0.15 and so here it is 0.15 and 0.85. So this is how we can solve these kind of tricky problems. So we are going to bring you many more problems with this chapter in the coming days. If you like this video, please do subscribe my channel. Thank you for now.